Hi, welcome to this demonstration of Corvera's HYDRx gas void fraction monitoring system. What we have here is a column of water contained in a clear section on the bottom with a bubbler stone at the bottom through a section of standard hydraulic hose. It's 30-inch, 1-inch diameter hose. And on top of the hose, we have a clear section of PVC piping where the hose is filled up to the fill line with liquid. As we add gas void fraction, we'll be able to see the level rise, and then by looking at how much the level expands, we can get a visual indication of the gas void fraction. Here's the output of our demonstration system, and we're showing two measurements of the gas void fraction. One from the difference in static pressure between the bottom and top of the column. As the air gets aerated, you'll see a decrease in the static pressure difference between those two pressure measurements, and you'll be able to determine the gas void fraction from that. And then our sound speed based measurement, which is shown in red. So we have two measurements, the differential pressure based reference in blue, and the speed of sound based measurement in red. And what we're seeing here is we're running at about 1.4% gas void fraction, which we just showed on the video, with a sound speed in the column of about 300 feet per second. As we increase the gas void fraction up to about 3%, a little more than 3%, the sound speed of the column of the mixture decreases to about 225 feet per second. And when we show the visual of the column, it's indeed about 3% gas void fraction. And we'll continue this, and we'll keep increasing the gas void fraction. We'll see the speed of sound decreasing with each increment in gas void fraction. And we can compare how the differential pressure measurement and the speed of sound based measurement agree or compare as we go forward at these increasing levels of gas void fraction. So now we're up to about 6% gas void fraction. And as we look at the clear section of the bubbler, we can see the bubbles have indeed expanded the volume by about 6%. And again, we'll keep running it. We get about a 2-second update rate from the system here. And we're holding it steady around 6%. And then we'll increase the level of injection further up to about 9%, a little short of 9%. And we're starting to see a little difference between the differential pressure-based measurement and the speed of sound measurement, but we are getting fairly large amounts of gas void fraction in the column at this point. So roughly around just a little less than 10% gas void fraction, and we'll increase it one more level here. And again, now the sound speed is down to 137 feet per second. And we're increasing it to about 12% between the differential pressure measurement and the sound speed measurement are still in pretty good agreement, and the visual indicator indicates around 12%. But again, now we're getting fairly large coalesced bubbles, and it's a fairly chaotic system in the bubbler column, if you would. But the sound speed is about 130 feet per second. For a GVF-based gas void fraction of about 11% at these conditions. Differential measurement saying 12%. Now we'll just decrease it down to about 9% again and conclude the demonstration. And thank you for watching. Again, this is a demonstration of the sound speed-based gas void fraction measurement by Corvera's HYDRx system. Thank you.